Hello everyone, today we will be discussing what is executable linkable file format. So, executable linkable file format or the ELF format is something that is understood by an operating system to run a C file. Okay, you have a C file, and then when you compile that, I hope you know हम GCC followed by the file.c ऐसे हम करके फाइल को कंपाइल करते हैं, ठीक है. एंड इफ़ यू डोंट नो, इस जान लो कि इससे ऐसे होता है. एंड अगर हम इसको कोई स्पेसिफिक रीनेम नहीं करते तो हमारी एक ए डॉट आउट करके एक फ़ाइल बनती है. एंड व्हेन यू डू ./a.out तो आपकी सी फाइल रन हो जाती है. एंड दिस a.out, इफ़ यू ऑलरेडी नो दिस इज़ एन ELF फाइल. दिस इज़ एन ELF फाइल. सो लेट्स सी ये होता कैसे है. I make a C file, for example, file.c. Suppose I am ready with my C file named file.c. So when I do gcc file.c and view the contents, so I have an a.out. I have an a.out here, and this is the ELF file. If you see the type of a.out by the file command, it will be, you can see it is a 64-bit ELF file. And suppose if I run that a.out, I can see my output. Welcome to Kernel Coffee. So let's understand how all of this is happening. So when you have a C file, here we have our file.c. You can have any file name, okay? I hope you are getting this point. It initially converts to a .i file. Now what is a .i file? A .i file is a C file only, but it doesn't have the macros. Like we write #include stdio.h. So you won't see it like this, like a normal C file. It would be a different type of a C file. So let's see how it's gonna look. For example, I did gcc file.c. As of now, I'm not saving this file. So this will just output the contents. This is our .i file. This is our .i file. You can see in the bottom of the file we have this int main only, but before this there is a shit ton of stuff. Like this is the expanded macros. There are no more macros here. It's just a C file, but slightly different one, of course. After this .i file, this .i file gets converted into a .s file. Now, what is a .s file? It is an assembly file. After getting converted into an assembly file, it gets converted into an object file. Can you guess what would be the type of object file? This is basically a binary file. It has machine code. It has machine code. Now this .o file gets converted into an ELF file. Now some of you might be thinking that when we have a .o file, which is a machine code, why don't we just run the machine code? Why do we need an ELF file? Because a machine code is understood by the machine, while an ELF file is understood by the OS. An ELF executable linkable file format, this is specifically to Linux. In MacBook, for example, you don't have an ELF. You have a masho file. Like that has its structure quite similar to ELF, but that is still different. So you cannot be having an ELF file in MacBook, of course. So let's see how do we get an assembly file as well as an object file and followed by an ELF file. Another thing, when you run an ELF, you get the output. To get an assembly file, we would be doing this file.c. Now you have a file named file.s. Suppose I do cat file.c. Oh no, cat file.s. Yeah. So you have an assembly file for this. And to get an object file, we can do is gcc-c file.c. So there you have an object file. But if you do it, you won't be able to understand it because this is machine code. Like, I guess we cannot understand this. And now to get ELF file from this .o file, what we would be doing is gcc file.o -o my ELF. Now we have this my ELF. And just for your information, this a.out and my ELF would be same. For example, I do my ELF, I get the output, and now I do /a.out. You get the output. I hope you now understand how a C file is processed into an ELF file and why do we need an ELF file. Because an operating system would understand an executable file, it won't understand machine code directly. So thanks for watching this video. For any doubts, do mention in the comments. Like, share and subscribe this video if you like the content in it. Do hit the subscribe button if you want more videos like this.